14.31, consider the following reaction. The rate law for the reaction is first order in CH3Br and OH minus. And then it says when this concentration and this concentration, the reaction rate is, what is the value of the rate constant? So we need to do a little bit of math here first by saying rate is equal to K, and then it's CH3Br times OH minus. And then we're going to solve for the units of the rate constant right here. We know this is first order and this is first order. And it tells us that the units of the reaction rate are molarity per second. And then K is what we want to solve for, and the units on the concentration are molarity, and the units on the concentration are molarity. And so we're going to have to divide this side by molarity squared, divide this side by molarity squared. Those cancel, and so we end up with K equaling, this cancels with one of these, 1 over molarity times seconds, or molarity -1 times seconds -1. Those are our units for the rate constant. Then in letter B it says, I apologize, B was actually the units for the rate constant, so let's relabel this B. And then A, it says what is the value of the rate constant. So now we have to put all these numbers in for the rate expression and actually solve for the numerical value of K. And so it tells us that the, well, let's just solve for K right here first. K would be equal to the rate and then divided by the concentration of CH3Br times the concentration of OH minus. So see how I took and divided both sides by this to get K alone. And so now we can put the rate value in, which is 0.0432 molarity per second. And then CH3Br is 5 times 10 to the -3rd molarity. And OH minus is 0.05 molarity, 10 to the -3rd. And now we need to take this and put this into our calculator, and then we get the value for K, which ends up being 1.7 times 10 to the 2, and of course we have units of molarity -1 times seconds -1. Then letter C, it says, what would happen if the rate of the concentration of OH would triple? Well, because the rate law is first order in OH, if OH is tripled, well, the rate triples, so the rate would triple. And then in letter D, it says, what would happen to the rate if the concentration of both reactants were tripled? So if this were tripled and this were tripled, then it would go up by 3 times 3, or a factor of 9. So it would be 9 times as fast.